Right now, sitting wherever you are, you're following 3 rules. You followed them when you woke up this morning. You followed them when you picked up your phone. You'll follow them when you go to sleep tonight. Every planet, every star, every grain of sand on every beach follows the exact same 3 rules. And the wildest part, for thousands of years, nobody knew they existed. Everyone, from the greatest ancient philosophers to the smartest scholars in medieval Europe, got motion completely wrong. For 2,000 years, the smartest people on Earth believed something that sounds totally reasonable. They thought that to keep something moving, you need to keep pushing it. Stop pushing, it stops. Makes sense, right? You push a box across the floor, you let go, it stops. Aristotle built an entire philosophy of motion around this idea, and honestly, if you just look around, it really does seem true. But Aristotle was dead wrong, and it took a guy sitting under a tree to figure out why. Newton's first law says something that sounds insane at first. An object in motion stays in motion forever, in a perfectly straight line, at the exact same speed, unless something forces it to change. Forever. No slowing down, no curving, no stopping. If you could somehow remove every force acting on a ball, air resistance, friction, gravity, all of it, and you gave it one tiny flick, that ball would travel in a straight line at that speed for the rest of eternity. The reason things stop on Earth isn't because they naturally want to stop. It's because invisible forces are constantly slowing them down. This is called inertia, and it's the reason seatbelts exist. When a car crashes, the car stops. But your body wants to keep going at 60 miles per hour. Inertia doesn't care that the car stopped. Your body is an object in motion, and it will stay in motion until something stops it. That something is either a seatbelt or a windshield. This is also why you stumble forward when a bus brakes suddenly. The bus stopped, but your body didn't get the memo. Inertia is not just a physics concept, it's the invisible force shaping your entire life. Now, Newton's second law answers a different question. If forces change motion, how much do they change it? The answer is beautifully simple. Force equals mass times acceleration. The heavier something is, the harder it is to speed up. And the harder you push, the faster it accelerates. This is why you can throw a tennis ball across a park, but you can barely throw a bowling ball across a room. Same arms, same muscles, same push. But 40 times more, mass means 40 times less acceleration. This one equation, force equals mass times acceleration, is hiding an incredible amount of power. Engineers use it to calculate exactly how much fuel a rocket needs to reach orbit. Doctors use it to understand the forces on your bones during a car crash. Sports scientists use it to optimize how a sprinter launches off the blocks. Every bridge, every airplane, every roller coaster was designed using this single equation. 3 letters, 1 multiplication sign, and it describes every push, pull, crash, and launch in the entire universe. And then there's the third law, the one everyone half remembers from school. For every action, there is an equal and opposite reaction. But most people get this completely wrong. They think it means karma, or balance, or that the universe is fair. It doesn't mean any of that. What it actually means is shockingly literal. When you push on something, it pushes back on you with exactly the same force. Right now, you're pushing down on your chair, and your chair is pushing up on you with the exact same strength. If it wasn't, you'd fall straight through it. This law is how rockets work in space. A lot of people think rockets push against the air to fly, but there's no air in space. Rockets don't push against anything outside. They push hot gas downward out of their engines, and the gas pushes the rocket upward with equal force. Action, reaction, no air needed. It's also how you swim. Your hands push water backward, and the water pushes you forward. Every time you take a step, your foot pushes the ground backward and the ground pushes you forward. You're not walking. The earth is throwing you. But here's what made Newton truly revolutionary. Before him, people believed the sky and the ground played by different rules. Stars and planets moved in perfect circles because they were divine. Rocks fell because they were earthy. Newton looked at an apple falling from a tree and the moon orbiting Earth and said, "Wait, what if it's the same thing? What if the moon is just falling toward Earth but moving sideways fast enough to keep missing? That single thought unified heaven and earth under one set of rules. 3 rules. And here's something wild. We recently discovered that Newton's first law was mistranslated for almost 300 years. The original Latin used the word quatenus, meaning insofar as, but translators wrote unless instead, which changed the meaning entirely. The original version doesn't say objects move in a straight line unless a force acts on them. It says every change in an object's motion is caused by outside forces, insofar as those forces act. It's subtle, but it's a completely different way of thinking about motion. Newton wasn't describing an exception, he was describing a rule. These 3 laws aren't just textbook stuff. They're why we have satellites beaming signals to your phone. They're why we can predict exactly where a spacecraft will be in 10 years. They're why engineers can build bridges that hold up millions of cars and never collapse. Newton gave us the operating system of the universe, and we've been running civilization on it ever since. Every technology you use, every vehicle you ride, every building you walk into, works because these 3 rules are absolutely reliable. So the next time you catch a ball, buckle a seatbelt, or just take a step forward, remember, you're not breaking any of these rules. You never have, and you never will. No one can. Not you, not a planet, not a star a billion light years away. 3 rules, written down by a man watching an apple fall, and 300 years later, they still predict everything. The universe is complicated, but the rules it runs on, beautifully, impossibly simple. If you like this video, check out one of these, and don't forget to subscribe.